Right, back on LeetCode doing some medium level questions, and I had just tried a linked list question, but I like the tree and graph questions and the sorting and searching questions. I think those are the most fun. So I'm gonna swing back over to some trees and graphs, and we're gonna try this one out. Binary tree in order traversal. Given the root of a binary tree, return the in order traversal of its nodes values. So if your input is 1, you'd have 1, null, 2, 3. And I guess you would, wait, root equals, is it just an array? Is that how it works? So you go 1, 2, 3. And I'm guessing if there's one here, it'd be 1, 2, 3, 4. Is that correct? I'm not exactly sure what an in order traversal is, so that might be part of it. The output here is 2, 1. 1, 3, 2. Oh, it's whatever's on the left. Is that right? Well, that's going to be the first challenge here. What's an in order traversal? Learn something new all the time. Like linear data structures, which only have one logical way to traverse, some trees can be traversed in many ways, following the general ways used for traversing trees in order. Oh, traverse the left subtree, then call in order. What? On the left subtree, visit the root, traverse the right subtree, call in order on the right subtree. Traverse the what? In case of a binary search tree, in order traversal gives nodes in non-decreasing order. To get nodes of binary search trees in non-increasing order, a variation of in-order traversal where in-order traversals is reversed can be used. That doesn't help me too much. Maybe one of these images. So go left, left, 1, 2, 3. Ah, okay. So I think I see what that last post was saying. So if it has a left node, you go to the left node and call it again. And I bet you can just do recursive function for this. So given a node, you go to the left and call it, and then you go to the right and call it. Call that function. So if you go to the left, call it, it will go to the left, call it. Well, if it's done, then it's done, and it returns. And then this goes to the right and calls it. So there's nothing on the left, nothing on the right. So it's done there. Goes back up. Now this goes to the right, calls the function again, goes to the left, there's nothing. It's done, it returns, goes to the right, calls it, goes to the left, there's nothing, returns, right, returns. I think that's what, so this helps me. I like that one, makes a little more sense. I'd never heard of an in-order in-order traversal before, so cool stuff. All right, so I guess what I need to do first is build the tree. The input's kind of weird. The way that, oh no, it gives a tree node. Okay, that's much nicer. All right. So I need to do I return? Recursive solution is trivial. Could you do it iteratively? Okay, well, just rained on my parade. Um, what do I output? Do I just output an array? Is that it? I guess. I don't. All right. We'll do output array. If there's none, it's an empty array. So what we need to do is if root dot left call Inorder traversal on root dot left with the same output array. If there's no root dot left, then we'll append our value to the output array and return. I have to sneeze. Alright, sneeze done. After this, we need to append ourselves. Is that right? If this might happen anyway, actually. I might not need this. I'll come back to that. Append root.val. And then we'll do the same thing with the right side. So we also want to call Inorder traversal on the right side with our output array. And so what I'm thinking will happen with the, I don't think I need to do this. I don't think I do. So the reason is because this will happen. So this will always happen. So in this, I would call it on the left. So if root.left, call it. If root.left, call it. If root.left, no. If, and then I append myself. And then if root.right, no, then I return. Root.left has already been called. It gets appended. So I think that's it. Yeah, I think that's it. And then at the very end, we need to return the output array, or the whatever you'd like to call it, traversal maybe, Inorder traversal output array. I don't really know what you want to call it. Is that it? That might be it. I kind of hope that's it. I hope it's actually that simple. Normally when I do these kinds of problems, I overthink them. So me thinking that, you know, just me thinking of this, maybe is not none. Maybe I'll add that in there. Maybe that needs to be in there. I imagine Python would cover it. But yeah. So what I was saying was, normally if I have a solution that is this easy, I normally try to overcomplicate it in my mind, and I think that it can't be this easy. But in this case, I have a feeling it is. Let's try it out and see what it looks like. Well, oh, I have to do self. That's why. Well, that was just my own fault for not being smart. Syntax stuff always gets me too. Well, look at that. My answer was correct. Okay, cool. Oh, we had a runtime error. Visualize. What? Well, that's interesting. Attribute error, none type object has no attribute left. Okay, so somehow I called it on none, and it tried to, okay, that's, if root.left is not none, well, it shouldn't have gone into this because it was none, and it's what it's saying is it called attribute num type has no attribute left. Okay. Um, uh, yeah, if root.left had a value, then I call this. And this is saying that it obviously didn't have a value because when I tried to call root.left, meaning root.left was none, which means root was none, which means that this was called even though it checks for none. So something something's not right with that, unfortunately. Maybe I don't need this. Is that it? I don't know if, let's see what run code does. So yeah, I'm confused by that. Yeah, I'm confused by that. Oh, it's because it starts as nothing? Oh. So, what? I guess if not root, return output array. I feel like that wouldn't. Okay. The input is nothing and my output is 132. Really? Are we sure about that? Hmm. Um. If is this how it is? Instance. I wonder if this is exposed to me. That's okay. I th I don't know how that. I'm very confused by this. I'm very confused by this. If it input nothing and I output 132, then um, what it can I print root? I'm trying to figure out what it's trying to give me because it doesn't really tell me here. It's just saying if root is, I guess if root is none, if I don't know. Yeah, so if root is none, then just return the empty array. Is the output array different? How did it? It looks like it's pulling it from here. So, uh, I'm a little confused by all this. I don't know why this isn't catching anything, and I'm very confused as to why standard out is saying that output array is something else. So oh yeah, that's how I would know, huh? Can I just say this is list int and then it defaults to that? Is that valid? That's valid. Has no problem with that. It's so weird that it just starts off, it's just 132. Um, okay. I mean, I know it worked for the other one. So maybe if I leave this out and do something along these lines, if output array is none, then output array is an empty list. Try to initialize it in here. Just gonna keep making sure it works on the run. No, it doesn't work there then. What in the world? So yeah, this wouldn't happen. I don't know what's happening with. I admit that my root, I didn't solve for that one, but it. I don't know. What if I just do that? If I just return an empty array. Now it's even weirder. Yeah, it's holding on to output array. Something's happening in the background of all this that's not doing good things. Yeah. Because I think what happened was I passed a blank array test, and now I'm in. It gave me. So I passed this one, and now it gave me this one. And it's still somehow holding on to that output array and feeding that in at the very beginning. I don't know how. Yeah, I don't know how. I guess somehow after this is called, I need to deinitialize this, but yeah, that's weird. Okay, I'll go ahead and take that out, and instead, what I'll do is return something from the output array, and So I'll just have them each return more or less an array, and then I'll just append the arrays onto each other as we go down. Left output is equal to that. So I'll do left output equals an empty array, and then I'll do left output or output array is equal to self dot val, sorry, root dot val plus left output. That's wrong. Oops. There we go. And then I'll do the same thing down here with the right output equaling this. And is this correct? So we go to the left if there's nothing. So yeah, but it would call if root left I could just not check that and rely on that, and then my left output would be blank if I called it on root.left and root.left was none. So I don't think I need these conditions anymore. This is my stop condition. Oops. So I have left output, output array, and then right output, and I'll go ahead and add this one in as well. Output array is going to equal output array plus right output, and then we'll return it there. I'm thinking that would work, but let's find out. Output array was referenced before assignment. Oh, whoops. I don't need that anymore. Alright, so I guess if you if you add parameters into these functions, I guess they mess up quite a bit. Yeah, because that, okay. This is the same idea. This was an implementation, is more or less the same idea as what I had originally with the extra parameter, but I guess just because LeetCode doesn't like that, it messed up everything and gave me some trouble about adding in that extra thing. So let's see, my runtime beats 53% of Python 3 submissions, and my memory was also about 50% better. So that's cool. What, it seems this is a weird graph. Oh well, passed it. That was the recursive solution. I might come back and try to do it iteratively, but we'll see what happens in the future. For now, that was binary tree in-order traversal, and I learned what an in-order traversal was. So thanks for watching.